Hello friends, welcome to Learner's Planet. Friends, this is our first session for quadrilaterals. In this session, we are going to discuss some basic concepts and terminologies related to quadrilaterals. We observe various shapes in our day-to-day life. I have shown some of the shapes over here. All of these are quadrilaterals. This is a rectangle, this is a parallelogram, this is a rhombus, this is a trapezium. So we have various shapes which are having four sides and four vertices. So the shapes which are having four sides and four vertices are known as quadrilaterals. Now what is the condition behind that? The figure should be, or the shape should be closed figure. Okay. Or we can say a plane figure that is bounded by four line segments. We call it a quadrilateral. Okay. Now let's understand the various types of quadrilaterals one by one. We see some quadrilaterals over here. Here it is a rectangle, here it is a trapezium, it's a rhombus, and it is a parallelogram. Okay. Now let's discuss one by one about each of these shapes. First of all, let's discuss about a parallelogram. A quadrilateral in which both pairs of opposite sides are parallel is called a parallelogram. Here we can see this quadrilateral is these two sides are parallel, these two sides are parallel, and we can see that the length of this side and this side is same, and the length of this side and this side is same. So we can call it as a parallelogram. Now what's necessary condition over here, that the length of opposite side should be same. It's not necessary that all the four sides should be same. Okay. Now suppose this is a parallelogram with us. Maybe this is A, B, C and D. This line is equal to, the length of this line segment is equal to length of this line segment. Then length of this line segment is equal to length of this line segment. Okay. Now let's talk about angles. This angle and this angle, that is angle A, will be equal to angle C. Similarly, this angle and this angle, that is angle B, will be equal to angle D. Okay. Precisely, we can say the opposite angles of a parallelogram are equal. Okay. Now, if we talk about diagonals, if we draw a line that from A to C, that will be diagonal of this parallelogram. Similarly, if a line is drawn between B and D, that will also be a parallel diagonal. Okay, let's draw it. So in this case, we can see two diagonals, that is AC and BD. So AC and BD are diagonals of the parallelogram. Okay. So let's have a quick recap. The length of these two line segments will be equal and these two line segments will be parallel. The length of these two line segments will be equal and these two line segments will also be parallel. These are the diagonals of the parallelogram and they intersect each other at the midpoint. That means we can say they bisect each other. That means this is the midpoint of this particular diagonal and this is the midpoint of this particular diagonal. That means they are bisecting each other. Okay, so this is the basic terminologies related to a parallelogram. Suppose this is the midpoint is O, so we can say OA is equal to OC, and similarly OD is equal to OB. Okay. Now let's discuss about a rectangle. What a rectangle is? A parallelogram in which each angle is a right angle. So we call it as a rectangle. Here we see the shape of a rectangle. Now all the four angles, suppose I write the name of the vertices as A, B, C, D. That means angle A, angle B, angle C, angle D. All the angles will be of 90 degree. Okay. Fine. Now the length of opposite sides will be equal. That is AB is equal to CD and AD is equal to BC. Okay. Now the third thing is diagonals. The diagonal BD and diagonal AC. In the case of rectangle, both the diagonals are equal. That means AC is equal to BD. Diagonals are equal. Suppose this is a midpoint O. So OC, OD, OA, OB. All the four line segments will be of same length. I just write it over here. OA is equal to OB is equal to OC is equal to OD. Okay. And definitely the diagonals bisect each other. Now let's see square. Square is a rectangle whose all the sides are equal is called a square. Okay. So that means suppose I write the name of the vertices as A, B, C, D. That means first of all the angles should be of 90 degree. So I can write angle A is equal to angle B is equal to angle C is equal to angle D is 90 degree. Then all the sides, that is AB, BC, CD and DA will be of same length. That is AB is equal to BC is equal to CD is equal to DA. Okay. Similarly, diagonals, that is AC and BD are of same length. AC is equal to BD. Diagonals are equal. Okay. Now one more important thing over here, that the diagonals intersect each other at O. We have already discussed that they bisect each other, but they bisect each other at 90 degree angle. This angle is 90 degree. Okay. So that's very important point. Diagonals bisect each other at 90 degree. We have to be very clear about it. Bisect each other at 90 degree. It's very important point. Okay. Now here we can see some parallelograms. Now what is the special in all these parallelograms? Here all the sides of these parallelograms are equal. Okay, in this case all the four sides are equal. In this case also, in these cases also, all the four sides are equal. So we call these sort of shapes as rhombus. Okay, now let's take the vertices as A, B, C, D. Okay, now what? Opposite angles will be equal. That is, angle A will be equal to angle C and angle B will be equal to angle D. Okay, as we have discussed in the case of parallelogram, where opposite angles are equal. Then all the sides are equal. That means just write it over here. AB is equal to BC is equal to CD is equal to AD. That means all the four sides are equal. Now what about diagonals? Both the diagonals of a rhombus bisect each other at 90 degree. Okay, that's very important once again. Both the diagonals bisect each other at 90 degree. Okay. but it is not necessary that the length of the diagonals will be same. Okay, in the case of rhombus, the length of diagonals will be different from each other. Okay. Now let's discuss about a trapezium. A quadrilateral in which one pair of opposite sides is parallel and a trapezium whose non-parallel sides are equal is called an isosceles trapezium. We can see a trapezium over here. I just put the name of the vertices. It's A, B, C and A. Okay. Now here AB is parallel to CD. This is the sign of parallelism. So AB is parallel to CD. Okay. It's necessary for a trapezium to have one pair of opposite sides as parallel. And we have also discussed about isosceles trapezium. If these two sides, suppose AD is equal to BC, these are actually non-parallel sides. If these two sides are equal, then we call it as an isosceles trapezium. Okay. Now, after discussing various types of quadrilaterals, we come to a conclusion that all the quadrilaterals like square, rectangle and rhombus are parallelograms. That means parallelogram is a superset and rectangle, square and rhombus are the subset of a set of parallelogram. Okay, that means rectangle, square, rhombus, all of them are various types of parallelograms. Okay. Now let's discuss angle sum property of a quadrilateral. That means we have to find out the sum of the four angles of a quadrilateral. Now let's begin to see it. The vertices are suppose A, B, C, D. We are finding the sum of all the four angles of any quadrilateral. It's not necessary to be a parallelogram, a rectangle, a rhombus or a square or a trapezium. Okay. The sum of all the four angles of all the quadrilaterals will be same. Now let's calculate what the sum will be. Friends, I have drawn a diagonal to this quadrilateral. Now we can very well see that there are two triangles. Now what is the sum of angles of each triangle? That is 180 degree, and we are having two triangles over here. That means definitely the sum of all the angles will be 360 degree. But in your examination time, you need to elaborate the same. So I just mentioned over here the steps to be followed. So let's begin. Now suppose I take it as this angle and this angle. Now this angle is CAB. Angle CAB plus angle CBA plus angle ACB is 180 degree. Okay. Similarly, in this triangle, I am talking about triangle ABC. Now, if I talk about triangle ADC, this angle, that means angle DAC plus angle ACD plus angle CDA. Still it will be 180 degrees since it is a triangle. Now we add both of them. That means this equation and this equation. Okay. Here angle CAB, this, and angle DAC, both of them will form angle A, that is angle DAB, isn't it? So it's angle DAB, or we can say angle A, the complete angle A. Similarly, angle CBA, that is angle B only. So I just write angle B, and here I can write angle ABC. Similarly, It's angle ACB, that is ACB, and angle DCA, or we can say ACD. This angle and this angle, that is angle ACB and angle ACD, they will form a complete angle C. We can call it as angle DCB or angle C. Similarly, this is angle CDA. I just write it over here. CDA is actually angle D. So addition of these three and these three will be 360 degree, that is 180 plus 180. Okay, so this is the proof of, or we can say establishment of angle sum property of a quadrilateral. That means we have proved that sum of all the four angles of a quadrilateral is 360 degree. Okay, so in your examination time you have to follow the given steps over here. Okay, now friends, let's discuss some basic theorems related to parallelogram and quadrilaterals. Now the very first theorem over here, that a diagonal of a parallelogram divides it into two congruent triangles. Okay, that we have to prove. Here we are given a parallelogram. So these are the vertices of the parallelogram, and we have to prove that this diagonal, that AC is the diagonal which is dividing this parallelogram into two congruent triangles. That means we have to prove that the triangle ADC is congruent to triangle ABC. Okay. So in examination, how would you write the step? First of all, what you have to prove. So it's to prove. Now what to prove? Diagonal AC of this parallelogram divides it into two congruent triangles, or we can say triangle ABC is congruent to triangle CDA. Okay, that we have to prove. Now the next step that you have to show is the construction. So in construction you have to join vertex A to vertex C. Okay, so what I would write, join AC. Okay, now next comes proof. So I just rub these lines from here. I hope you might have been clear about it. Now proof. The first thing we observe over here about the alternate interior angles. Now we can see the line AD is parallel to line BC since it is a parallelogram. Similarly, line CD will be parallel to line AB. That means this line, that is AC, will work as a transversal to these two parallel lines, and simultaneously it will work as a transversal for these two parallel lines. Okay, that means this angle and this angle, that is we can see a shape of Z over here. So this angle and this angle, both angles will be same since they are alternate interior angles. Okay, so I just write it over here. Angle DCA will be equal to angle BAC. It's alternate interior angles. Okay. Similarly, we can see this shape of Z. So this angle will be equal to this angle, that is angle DAC will be equal to angle ACB. Further, it is alternate angle. Then we see a common side, that is AC is equal to CA. So we have 1 point, 2 point and third point. Okay, so from ASA congruency, that is angle side angle, that is the two angles and side included between them, that is angle side angle. Okay, so it's ASA congruency, hence we can say these two triangles are congruent. That means triangle ABC is congruent to triangle CDA. Okay, I'm sorry, I missed one step. For ASA congruency, we can establish by making these two angles equal. Okay, so I hope you are clear. Now let's see the next theorem. In a parallelogram, opposite sides are equal, that we have to prove. Okay, now we have been given a parallelogram over here. It's A, B, C, D. Okay, now what's given? A, B, C, D is a parallelogram. And what we have to prove? AB is equal to CD and BC is equal to AD. Okay. Now proof. To establish this statements, that means AB is equal to CD and BC is equal to AD, first of all we have to prove that these two triangles are congruent. That means triangle ABC is congruent to triangle CDA, that we have established just now. In the previous theorem itself, we have established that these two triangles are congruent. Now what happens if the two triangles are congruent to each other? That means they can be superposed on each other. Okay, that means what? All the three sides and the three angles of both the triangles will be equal. Okay, so we have already established that the two triangles are congruent to each other. The steps you can take from the previous theorem also, so I won't repeat that particular part. So here you just have to follow the steps. Then finally you can write that from CPCT, what CPCT is? Corresponding parts of congruent triangles. I just write it over here. Corresponding parts of congruent triangles. Okay, so by CPCT we can say side AB will be equal to side CD and side BC will be equal to side AD. Okay, and moreover we can also write that angle D will be equal to angle B and angle A will be equal to angle C. That is all with CPCT, that is corresponding parts of congruent triangle, since both the triangles are identical in each respect. Okay, I hope you are clear. You have, in your examination, you have to mention the previous part which I am not writing over here, because it will be an unnecessary repetition of the same thing, right? But you have to mention in your exam. Now, in this theorem, we have to prove that the opposite angles of a parallelogram are equal. Suppose in this parallelogram, this is A, B, C, and D. And we have to prove angle A is equal to angle C and angle B is equal to angle D. That we have to prove. Now, how do we do that? Let's write down the steps. Proof. Now, since it is a parallelogram that is given to us, AB will be parallel to CD. I'm sorry, it's parallel to CD. It's given. Now, AB is parallel to CD, so BC will work as a transversal. Okay, so BC is a transversal. If BC is a transversal, that means this angle and this angle, the sum of them will be 180 degree. Why they will be 180 degree? Because these are interior opposite angles between two parallel lines. Line CD is parallel to line AB, and these are the interior opposite angles. So their sum will be 180 degree. So what I can write is angle DCB plus angle CBA will be 180 degree, and these are interior opposite angles. Okay, I can write down in short also. It's angle C plus angle B will be 180 degree. Similarly, these two lines are parallel, so CD will work as a transversal. That means this angle and this angle. I just change the color. This angle and this angle, that is angle C plus angle D, they will also be of 180 degree for the same reason. They are also interior angles, opposite angles between these two parallel lines. So the same reason. Now what we can do, this is 180 degree and this is also 180 degree. So we can equate them. So it's angle C plus angle B will be equal to angle C plus angle B. So angle C can be cancelled from both the sides. So we can write down angle B is equal to angle D. Now similarly we can prove that angle A will be equal to angle C. Isn't it quite simple? So in your examination, this friends, we will be taking more theorems and questions based on quadrilaterals in our next session. So till then, do revise this particular session, and let's see you in the next session. Bye-bye.